All right, we are starting chapter 7, so this is section 7:1. Chapter 7 is all about systems of equations, and what that means is there's going to be more than one equation at a time. So we're going to do 2 equations. Once you get to Algebra 2, you'll do 3 at a time, but systems of equations just means you have 2 equations at the same time. We are mostly going to focus on linear equations, so we're going to be talking about lines. And the entire chapter, the whole point is to find where 2 lines intersect. That's your answer, okay? Your answer that you're going to be able to find is where the 2 lines intersect. How you find that answer changes throughout the chapter, but the goal is the same every single time. We're just going to learn different methods of getting there. So today we're going to start by graphing them. So graphing is the first method we're going to learn how to do to solve systems of equations, and you're looking for where they intersect. So a system of equations is just 2 or more equations together, and the goal is to find where they intersect. And we're talking about lines. So if you think about lines, the most 2 lines can intersect is just once, okay? So 2 straight lines, think about them intersecting. There's no way that they can loop back around and cross in an additional place. So 1 is the most, as many intersections as you can get. Now, you can have no intersections because parallel lines never intersect. So if you have parallel lines, then you won't have any solution to the system because they will never intersect, and the whole point is to find where they intersect. The infinite solutions happens if you end up with the same line. So 1 line right on top of the other one, then they will always intersect. Okay, so those are the 3 options. Most of the time we only have 1 intersection, but infinite and never happens sometimes as well. So this is what it looks like graphically. So 1 solution has an intersecting line, independent, they do what they want. The solution to this system would be where those 2 lines intersect, which is at the ordered pair 1, 2, okay? So the answer, if this was something we were trying to solve, it would be 1 solution, and then this is the answer, the ordered pair 1, 2, because that's the point where they intersect. Infinite solutions means that they're the same line. So these lines would be like on top of one another, so they intersect in every single spot. So you can't list all the intersections because they intersect everywhere, so you just say infinite solutions, same line. No solution happens if they're parallel because we know parallel lines never intersect. They have the same slope, which means they increase or decrease at the same rate, and they're never going to cross. And so to find the number of solutions today, we are going to graph them, and your solutions are going to be an ordered pair. So the solutions are going to be an ordered pair this entire chapter, no matter which method we're using, but today we're going to start with graphing, and we're actually going to graph them in Desmos, not by hand, because it's more accurate, and on your state test you'll have Desmos available to you. So use Desmos to find the number of solutions for the following system. So all I'm going to do is I'm just going to split screen with Desmos so that it's easier. And you can just put the equations in Desmos exactly how they're given to you. You don't actually have to put them in slope-intercept form, although this is in slope-intercept form, but we're just going to throw them in there. So y equals negative, which is the subtraction sign, x plus 5. And then in the second line, we're going to put y equals x minus 3. And once you have that, it graphs the 2 lines. And so we can see that they intersect once. And the point where they intersect is at 4, 1. You can tap it to get that intersection point. Okay, so there is 1 solution, because they intersect once, and that solution is 4, 1, because that's the point where they intersect. Okay? We'll go to the next one. Again, the first one's already the same, so we don't even have to close that one out. The second one, I'm going to go ahead and close the x and then graph the new line. So 2x plus 2y equals negative 8. We don't even have to put it in any specific form. It'll graph it no matter what. Okay? As we zoom in and out, we see I'm not really finding any kind of intersection. They look pretty parallel. Okay? So I'm guessing that this one is no solution. Now, to To make sure, I'm going to put these into slope-intercept form so that we know. Because we know parallel lines have the same slope. This first equation is already in slope-intercept form. So we already know that the slope is -1/1 because it's the number in front of the x. And our starting point is 0, 5. The second one, we can go ahead and get that in slope-intercept form first. So we're going to start by subtracting the 2x from both sides because it has to be in y equals format. So 2y equals -2x minus 8. Divide everything by 2. So y equals -x minus 4. So in this equation, that's now in slope-intercept form, the slope is -1/1, and my starting point is 0, -4. So I can confirm that these slopes are the same. So these have no solution. And when you have no solution, you have to tell me why. So no solution, parallel lines. But what about parallel lines gives us no solution? The fact that they never intersect, okay? Because that's the whole thing we're looking for, is where they intersect. So parallel lines have no solution because they never intersect, and you tell me all of those things. All right, so this one, if we're looking and working smart, we can see that that first equation I already have in here. So I'm going to close that one out and switch this instead. Y equals -x minus 4. And I'm looking around and I only see one line. So a good way to test that in Desmos, if you tap the circle that has the color on it, it'll go away. So if I tap this little purple circle off to the left, it'll make the purple line go away and keep the green line. If I put the purple line on, we can see it falls right on top of that green line. There are two lines there. They just, if you take the green one away, the purple line gets lighter. So you can see that they're both there, but they're the same line, okay? So this is infinite solutions. And similar to when you had no solutions, you had to tell me why. So infinite solutions because they always intersect. And it is because they are the same line. If you wanted to prove that, you could isolate the y in that first equation, which we actually already did up here. So if I grab that, this is what we got from isolating the y. And if you look, they're the exact same equation, okay? You have the same slope and the same starting point, which makes them the same line, which means you'll have infinite solutions. Okay, last one we're going to do. We have a -x plus 8. Oops, I forgot the y equals. Y equals -x plus 8 and y equals 4x minus 7. And I see there's just two normal lines, which means they have one solution, and they intersect at the point 3, 5. So that's one solution. And then the solution is 3, 5. Okay? So we understand that that's because they intersect once, and that is where they intersect. And now I want to just kind of make sure you understand what that means algebraically. So graphically, it's because that's where they intersect. Algebraically, that's what this is for, checking our solution. If we plug these in, if we plug the 3 in for x and the 5 in for y, it will make both of these equations true, or it should, okay? So we're plugging 3 in for x and 5 in for y. So for my y, I'm plugging in 5 equals negative, plugging in 3 for x, plus 8. And I'm checking it. So my left-hand side's already just a single number, so I'm leaving it. And this is just -3 plus 8, and -3 plus 8 is 5. So 5 equals 5, that is true. And I come over here and do it to this equation as well, plugging in 5 for y and 3 for x, and then making sure it's true. So 4 times 3 is 12, and 12 minus 7 is also 5, so this is true as well. So that's graphically, they intersect in that place, but algebraically, that's the only x and y that is going to make both of those equations true, okay? There are other points on those lines, but they don't share that point, okay? Those two lines only share this one point, which makes both of those equations true, okay? So systems of equations, two lines, we're finding where they intersect, and then if we know that they intersect there, it should also make both of those equations true. For your homework, you just have to graph on Desmos. Just make sure you put a screenshot of the graphs in there as well, and tell me how many solutions and what they are. That's it.